Welcome. So this is the demo for Lab 1. The way you would access that is to go to Blackboard, then click into your class, and click on the Labs tab, and you should see Lab 1 here. Once you click inside, you'll see a document that will explain the problem to you, and then you should see a zip file. So this will contain all of your files. So what you want to do is you want to extract this into a folder on your desktop, and then go to repel it, and then drag and drop all the contents of that folder in here. So I hope that was clear on how you set this up. But another thing you'll see here is the PDF document. What it will tell you is that the input file contains a string, just one string, and it may be totally empty. If it's totally empty, you are supposed to print no permutation to the output. If there is a string there, then you would have to print out all the permutations of that string, all of the unique permutations. So it's important at this point to make sure that we know what the requirements are. So if the string is empty, we print no permutations. But if the string is there, then we print the unique permutations of that string in alphabetical order. Let's say we have a test string, A, B, and C. How do we get the permutations of that? Well, we're going to have to swap characters essentially. So let's say we tried swapping the first character. What are all possible swaps from the first character? So one swap you could have is to swap A with A, which would not change the string at all. Another possible swap is to swap A with B, which would produce the string B, A, C. And the last possible swap that you have is you could potentially swap A with C. So now you have C, B, A. Okay, so once we get to this letter, we are going to fix the first character in place. We're not going to mess with it. We're just going to mess with the remaining characters. So what are all the ways that you could potentially swap B and C? You can swap B with itself, in which case the original string doesn't change, so you have A, B, and C. Another way you could swap it is B with C, which would produce A, C, B. The two ways you could swap A and C in this situation would be to swap A with A, which would not change anything, and you could swap A with C, which would produce B, C, A. And we could go through the same process here. So that if you swap B with B, it's C, B, A. And if you swap B with A, you get C, A, B. So now, if we were to label all the levels of this tree, if this were level 1, if this were level 2, and if this were level 3, you would realize that once you get to level 3, you have all of the permutations that you need. So everything here is all possible permutations of A, B, and C. So we have to come up with a base case where once we arrive at level 3, we need to sort of register that this string is a permutation, and we need to move on. Okay, so what could a base case be? I've already talked about the fact that we fixed the first letter, but at level 3, you could think of it as fixing the second letter as well. And if you fix the second letter, you're in a situation now where you only have one character left. And when you have one character left, we could say that that is the base case. That once there's one character remaining, register this string as a permutation of A, B, and C, and move on. So let's write that down. The base case is one character left. Now I know it's hard to tell what that means, but once we get into the code, it'll make more sense. Okay, so I keep saying that after one character left, we move on. What do I mean by that? What I mean by that is that at some point, for example, once we hit this particular permutation, at some point we have to go from here all the way to another permutation. So it could be here, or just any one of these. And to do that, we essentially have to reverse the operation that we did to get down here in the first place. So we have to swap the characters back. So in this instant, we swapped B with B. we'd have to swap those back. Now I know for this it doesn't matter, but for this particular permutation it does. So to get down here, we swapped B with C. Well, we'd have to swap those back to go back up. And we'd have to do another swap to get back over here. And then we can, the recursion will head down a different branching pattern. So that's another thing we have to note, that to backtrack, and backtracking is one of the magical properties of recursion, which is really hard to get otherwise. So we have to backtrack to a parent node in the tree. That means we have to swap back. Backtrack by swapping back. And the last thing we should probably understand is this is all happening via swap. So we need a swap function. Okay, we have all of our notes written up here, so everything we've talked about thus far. And we can sort of go through this list. The first thing we can knock out real quick is the swap function. So our swap function is not going to return anything. Excuse me. But what it will need is the string and the two integers that will be swapped. And I'm sure you guys sort of know how the story goes here. So we'll save it in I. Then we'll say string I. We'll overwrite string I with string j. And then finally, we'll overwrite string j with temp. And easy peasy. And because we're passing by reference, the original string should change. So the next problem that we're going to solve is that all perms should be unique. And in C++, there is a data structure called a set, which will only accept, you can only insert into it unique elements. So it will check for you whether elements are unique or not. And it does this very efficiently. So that's what we're going to use. In our main function, let's instantiate a set. This will be a set of strings because all of our permutations are going to be strings. We'll call this perms. Keep it simple. The next thing that we should probably tackle is this very first one. So if the string is blank, then we should be printing no permutations to the output. So we do need a string for that. So let's call this string str, and we'll instantiate it to blank just to test out our code. And then if string equals nothing, then we will see out no permutations end line. So I don't think there was a new line in the output, so let's just leave it like that. And let's run it. That's C++ for you. Hey guys, okay, I did some debugging and I included string. I also deleted the lab file down here, which turns out that was the problem. And everything worked just fine. So if I run this, it'll say no permutations. Now we're at the meat and potatoes of our function. Let me just adjust this so we have more viewing area. Okay, so we're going to call this, I mean, you can call it whatever you want. I'm going to call it permute string. And we'll comment this out for now. But permute string will not be returning anything. But what we will be giving it is the string by reference, because we're not going to need more than one string. We also need the size of the string. We need access to the set, so because there needs to be a place for all the permutations to go. So this is perms, and we'll pass this by reference, so we're working on the same set at all times. And we will also need something called the start index, which we will default to 0. And the start index is very important because what it keeps track of is the fixed characters. So if you remember, when we were talking about a tree, eventually we fixed one character in place, and then we just were working with the other two. So the start index will help us keep track of that. And what's more important is that it will help us identify our base case. So let's just write here base case. So if start index is equal to size minus 1, and just to be safe, I'm going to do less than or equals to, is equal to size minus 1, then we will do our base case. We'll execute this block of code. And what is that? Well, if we're inside this block of code at line 25, that means that we are in level 3 of our tree, the very bottom level where all the permutations are. So what we can do is we can insert those perms into the set. So we'll take the string and we'll insert it into the set, and we will get out of there. Like we're done. We got our permutation. Now we can let the code continue executing. All right, guys, we're finally at the hardest part, which is the backtrack by swapping and the actual recursion bit of it. So I'm gonna try to be thorough here, but we'll see if I'm effective. But here we're gonna start looping. We're gonna do a loop, and we're gonna have int I is equal to 0. No, it equals to start index, and you'll see why in just a minute. I less than size, because we're looping through the whole string. I plus plus, or let's do plus plus I just to be thorough here. Okay. So what's going on in here? So first, if you will recall, we were doing some swapping. So first we have to swap the characters. Now initially, start index will be 0, so it will be pointing to the index of the first character. So our first swap will be the first character with the first character, and this is at level 1 of our tree, where none of our permutations exist yet. So it's okay to swap A with A, for example. But our swap function up there is going to need a string, and it's going to need the first index, which is going to be our start index. That's our A, and it'll swap with I. And initially, I is going to equal our start index, so we're really just swapping A with A. And then comes the recursion. So we're going to call the same function again. Then we're going to pass in the string, we're going to pass in the size, which hasn't changed. We're going to pass in the set, but this time we're going to pass in start index plus 1. And I want you to think about what this is going to do. This means that when this function gets called, instead of pointing to the very first character, so for example, here's A, B, C. So instead of pointing to A, it's going to be pointing to B, which means it's going to be swapping with these last two characters, which means it's going to go down to level 2. The first character will be fixed in place when this happens. And then once we come out of that recursion, like we're sending, with line 33, we're sending it down the recursion tree, okay? But with line 34, by now, the recursion has already happened, and we're trying to backtrack. On line 34, we're trying to backtrack. So what we have to do that is to swap back. We're going to swap back. We can use exactly the same indexes. It's totally fine. I mean, we could even swap these, 2 arguments. For simplicity, let's just keep it just like that. And I want you to be clear about what's happening. So in just a second, I'm going to show you the tree. Guys, I'd like to make a very quick correction. I had this as less than or equals to. That is incorrect. This is equal. Sorry about that. Anyways, let's see what happens when we execute this function. So when we first execute the function, the start index is equal to 0. And the size of the string, which in our case is 3, 3 minus 1 is equal to 2. So initially, the base case will not be hit. In fact, the very first thing that ends up happening is the for loop executes. So let's see what's going on. Initially, the start index is equal to 0, and I is initialized to the start index. So essentially, they're both the indexes of the very first character. So S is over here and A is over here. So what happens next? Next is the first swap. And in this case, we're essentially swapping A with A. Once that A to A swap is done, we recurse. And everything gets passed, the string, the size, the perms. The only difference is we increment the start index on the next level. So let's run this again, except with an incremented start index. So start index is 1, the size is 2. These two are not equal quite yet. So the for loop executes. In the for loop, the start index is now incremented, so it's 1, and the index at this level is also 1. because it's initialized to the start index. So it's pointing at, oh, excuse me. So it's pointing at this B over here. So S is here and I is here. They're both pointing to the same character. Next, the permute string gets called. So essentially, we are heading down this branch to this particular situation, to this particular leaf node. And at this point, something different happens. So a start index gets incremented one more time from 1 to 2. So here it equals 2. In size, which is 3, 3 minus 1 is equal to 2. So now we've hit our base case. And inside our base case, what happens is this permutation will get inserted into our set. And we will return. And this is very important because there is a second swap that has been waiting to execute that is now going to get a chance to execute. Because now, one level up, we're finally returning from this permute string function. So now, once this executes, the string is being returned to its previous state. And once the string is returned to its previous state, the loop will increment. So at level 2, S was equal to 1 and I was equal to 1. Well, now I is being incremented to 2 because of the loop. And once we look at swap, hold on. So once we look at swap, we'll see that B is now being swapped with C. So B is being swapped with C. And then permute string will get executed with I incremented by 1, and it will hit the base case again. And this string will now be inserted into the set for the exact same reason our first was. And then this return statement gets hit. Once the return statement gets hit, we return to one level up. The second swap, it has been waiting to execute. It goes ahead and executes. The string is returned to its previous state. So the string is returned to its previous state, and we realize that the loop increments. So now I is equal to 3, which is not less than the size. The size of this is 3. So I is equal to the size, which means this loop is now completed. It's done executing. And an implicit return statement, I haven't written it here, but it's actually implied. It gets hit, and this loop is done, which returns control to level 1. And at this point, this loop at level 1, the loop increments. So let's erase all of this stuff because we're done with that branch, and let's increment the loop. So at this stage, S is 0 and I is equal to 0, but now we're incrementing I. So we can erase this and point it to B. We're incrementing it to B. And now this goes down here, like A and B swap, so you end up with this particular string. The permutation happens, so we're one level down now, and S is pointing here, as is I, and now we swap A with the first character fixed, and we hit our base case. Which means now that we've hit our base case, the second swap hits, which returns the string to its previous state. It also returns control to the previous state. And I gets incremented to C. And so on and so forth. You know, eventually, everything is going to, every single thing in this tree, every single leaf node is going to get hit. So that's essentially how our permutation algorithm is working. I hope that made sense. I know there's a lot of scribbles, but if you're a visual learner, hopefully, you know, will appreciate it. You'll appreciate it. Thank you. Alrighty, we've done most of everything that we need to. We just need to now sort. Well, let's do some housekeeping down here. Now that we have this permute string function written, let's go ahead and pass in all our variables. So this will be string.size. The perms will be perms, and start index, we don't really need to worry about that because it's defaulting to 0. So here's the thing. Even though we have a set, we need to be able to sort, to print the permutations out in a way in which they're sorted. And there is an excellent function called sort in the algorithm library. Algorithm. I believe that's it. Is that correct? Algorithm. There you go. Okay, so there is a function in the algorithm library called sort that we can use to do this quickly. The only issue is that it doesn't work on sets, but it will, however, work on vectors. So we have to convert our set into a vector. So let's include the vector library. And so how do we convert, a set into a vector? Let's populate the set with permute string, and then we will initialize a vector. So vector string perms. Let's call it perm v. Okay, and we'll make it capital so we know that this is a vector. So now, so at line 48, our set gets populated. Now let's loop through our set. We can use a for each loop. So it'll be auto. We can do string perm of perms perm v dot pushback perm. Okay, and this will convert the set into a vector. Finally, we will call the sort function on the vector. So perm v dot begin perm v dot end. I believe this is how it's done. You can look at the documentation. I'm surely going to when I execute. And then lastly, we have to print out all the permutations. So let's loop through the permutations again, the ones that are in the vector. We're going to print out the vector because that is now sorted. The set isn't sorted. And then I'll see out the perm and line. Let's run that and see what pops up. It should be okay. No permutation. Okay, let's set the string to A, B, and C, our favorite string. Okay, there we go. And there you have it. This is a sorted, unique permutations. Hey guys, we just now need to convert this file into something that is submittable. The thing is, college, there's only really two reasons to go to university, and that's to learn things and to get credentialing. And we've learned about as much as we can from this homework. It's time to get our credentialing. I think we need a few libraries here. Let's see here. Let's include fstream. Include. We got fstream and we got string. All right, we should be good. Oh boy, I'm tired. This whole making video stuff does take a long time, doesn't it? Okay. Well, argument manager I believe that's it. You know what? I'm just going to copy paste a bunch of this. I'm just going to go ahead and copy paste it. Okay. And we also need to define argc and argv. Argc is an integer, and argv, if I remember correctly, is something like this. Okay. Right now we are manually putting in the string. We actually need to get it from the input file. So I would recommend just using getLine to do that. And we still use the string variable. It's just we wouldn't, initialize it. If you hit Alt up, it'll just move the line up for you. Okay, so we got the string in this line. We put it in file. Then, well, before we don't need these variables just yet. We'll do it over here. We'll initialize them here. And here's the thing: if the string is empty, we don't want any other code to execute beyond that. We'll just put a return statement there, and that'll block the control flow from going below line 45. The string is there, then we'll execute the rest of this stuff. The only issue now is that instead of printing to C out, we need to print to the out file. So let's just do that. And we don't necessarily need these. I don't even know why I put them in there. I think that should be it. You might have to test it out. You might have to debug it a little bit, but that should get her done. All right. Thank you guys very much. I'm going to put this all in Pastebin, and you should see a link in the description. And I would be remiss if I did not mention Cougar CS. So you might not know this, but in the spring of 2021, I'm actually the director of tutoring at Cougar CS. So I hope I have not disappointed. Likely I have disappointed, but it's whatever. So if you guys want, please hit me up on Discord, send me a DM, and I am more than happy to invite you to our server. And we do have other tutors out there who are really cool guys and very competent. So just let me know. Thank you.